Many teams adopt model-based systems engineering with the best intentions. They start building models, they create blocks, diagrams, interfaces, and behaviors. The tools are powerful, the diagrams look impressive, but something subtle often goes wrong. The model grows quickly, yet the system itself becomes harder to understand. Why? Because the model was built without a clear foundation of requirements. And this is one of the most common mistakes in early MBSE adoption. In this video, we'll explain why requirements come first in MBSE, what happens when they don't, and how requirements provide the structure that keeps the entire model aligned. The purpose of MBSE. To understand why requirements come first, we need to step back and remember the purpose of MBSE. MBSE is not about creating diagrams. It is about creating a connected representation of the system that allows engineers to reason about design decisions. The model becomes a structured way to understand what the system must do, how the system behaves, how components interact, how performance is evaluated, how verification will occur. But there is one critical question that must be answered before any of those activities begin. What problem is the system supposed to solve? That answer is captured in requirements. Requirements define the intent of the system. Without them, modeling becomes speculation. Requirements define the system's intent. Every engineered system exists for a reason. A spacecraft must communicate with Earth. A radar system must detect objects. A vehicle must transport people safely. Requirements capture what the system must achieve. They define capabilities, constraints, performance expectations, and operational conditions. In MBSE, requirements become more than just text in a document. They become anchors inside the model. Every major element in the system should connect back to a requirement. This creates a clear line of reasoning. Requirements drive behavior, behavior drives architecture, architecture supports verification. Without requirements at the beginning, that chain breaks. What happens when requirements are skipped? When teams begin modeling before requirements are clear, several problems appear. First, architecture becomes arbitrary. Engineers begin defining components based on assumptions rather than needs. Second, behavior modeling loses direction. Activities and interactions are modeled, but there is no clear reason why they exist. Third, traceability disappears. Without requirements at the top of the model, it becomes impossible to answer a critical engineering question. Why does this element exist? And when change inevitably occurs, the impact becomes difficult to evaluate. Good systems engineering always asks, what requirement does this support? When that question cannot be answered, the model has already drifted away from the system's purpose. Requirements as the starting point of the model. In a well-structured MBSE approach, requirements provide the starting point for system reasoning. The process typically unfolds in a logical sequence. First, stakeholder needs are captured and analyzed. These needs are refined into system requirements. Requirements define the outcomes the system must achieve. From there, engineers begin exploring system behavior. What functions must exist for the system to satisfy its requirements? Next comes structure. What components or subsystems are needed to support those behaviors? Finally, verification planning ensures the requirements can be tested and validated. This progression keeps the model aligned with the system's original intent. Requirements are not just documentation, they are the North Star of the model. Traceability. One of the most powerful benefits of MBSE is traceability. Traceability allows engineers to connect requirements, behavior, architecture, verification. This means every element of the model has a clear purpose. If a requirement changes, engineers can trace exactly what parts of the system are affected. This dramatically reduces risk during design changes. Instead of guessing the impact, the model shows the relationships explicitly. Traceability also improves communication. Program managers, engineers, and test teams can all see how design decisions support mission goals. And that transparency is essential for complex systems. How methods like OSEM use requirements.
This requirement-first mindset is also reflected in structured MBSE methods such as OOSEM, the Object-Oriented Systems Engineering method. OOSEM provides a step-by-step approach for developing a system model in a disciplined way. And importantly, the method does not begin with architecture diagrams or system components. It begins with understanding stakeholder needs and defining system requirements. From there, the method guides engineers through a logical progression. First, stakeholder needs are analyzed. Those needs are translated into clear system requirements. Next, engineers explore system behavior, identifying the functions required to satisfy those requirements. Only then does the method move into logical and physical architecture development. This sequence ensures the model evolves in a structured and traceable way. Every behavior, every interface, and every architectural element can be traced back to a requirement. This disciplined progression is one of the reasons OOSEM is widely used in large engineering programs and complex systems development. If you're interested in learning how this works in practice, we cover the full OOSEM workflow step by step in our SSA OOSEM training program. The training walks through how stakeholder needs, requirements, behavior, and architecture are developed and connected inside a real MBSE model. You can find the link in the description below. MBSE succeeds when the model reflects the true intent of the system, and that intent begins with requirements. Requirements define the problem, they guide behavior, they shape architecture, and they provide the foundation for verification. When requirements come first, the model becomes a powerful engineering tool. When they do not, the model quickly becomes disconnected from the system it is supposed to represent. If you're interested in learning how requirements, behavior, and architecture fit together in a structured MBSE approach, we cover this step by step in our MBSE training program. You can find the link below. And if you found this helpful, subscribe for more MBSE Simplified, model-based systems engineering without the complexity.